Hello. We're going to look at paper 2 of the practice exams for April's 2018 exams. So we're going to look at this video will cover questions 1 and 2. So I have a question number 1 is a raft sliding down a ramp into some water. I see that I have 50 meters, 22 degrees. I see an 8 kilogram here. Again, the 22 and the 50. Another 52 kilograms here. And a force of friction of 180 newtons. So the first thing that we want to do is calculate the component of the weight. So weight being mg of the child and the raft parallel to the slope. So if I draw my free body diagram, I've got my Fg, force normal, and then the force parallel to the slope would essentially be the force net if there were no friction. So how does that look in a normal or a revised free body diagram? We're actually looking for this component. So this being 22 degrees, this being mg or Fg. We could say that, let's start with Fg is 60 times 9.8, which gives us 588 newtons. Then because we want this component of it, we're going to, so that's the opposite over the hypotenuse. So we're going to use sine. So we're going to say that the force parallel is equal to Fg sine theta, which is going to be 588 times the sine of 22, and our force parallel will then be 220 newtons. Sorry. Show that the acceleration of the child in the raft down the slope is 0.67. So that's what we're saying. That's what we're going to find. We're showing that. So if I know that my force parallel is 220 newtons, so that's down the ramp. I have some force friction acting up the ramp. So if this is 220, this is 180. So my net force is going to be this 220 minus the 180. So my net force is going to be 40 newtons. Using Newton's second law, F net equals ma. 40 equals 60 times the acceleration. A equals 40 over 60, or 0.67 meters per second squared. Okay. Finally, or not finally, letter C, calculate the speed of the child at the bottom of the ramp. So now I'm starting to talk Suvat equations. So let's list those out here and see what I have. I have a distance of 50 meters. I have an initial speed of 0 meters per second. I have a final velocity of, that's what I'm trying to find out. I have an acceleration of 0.67 meters per second squared, and I do not have any time anywhere. So looking through my Suvat equations, I would want to find an equation that is going to have those 4 without the time. And I have v squared equals u squared plus 2as. So v squared equals 0 squared plus 2 times 0.67 times 50. And I get v squared equals 67. So then I find the square root of both of those. V equals the square root of 67, which is approximately 8.2 meters per second. Okay. Letter D, a child, smaller mass. So, less mass, therefore less Fg. Less Fg, therefore less F parallel. But our force of friction remains constant. So if I have a smaller force parallel, but my friction remains constant, then that force net so therefore my force net is going to decrease as well, meaning that I have a decrease in acceleration. If I have a decrease in acceleration, going back to my kinematics equation, v squared equals u squared plus 2as. If I decrease my acceleration, but everything else remains constant, obviously, or maybe not, the velocity is going to decrease too. So, smaller mass of the child, constant friction, therefore less acceleration, less final velocity. Okay? We'll call it lower final velocity. Okay, and that's question number 1. Question 2 deals with some specific heat. So we have an electric kettle, minimum of 650 cubic centimeters. If we look at some of the conversions, this problem is, there are a lot of conversions that you're going to need to work through. So 650 cubic centimeters, 1 cubic centimeter equals 1 gram. So this is going to equal 650 grams, and it's also going to equal 0.650 kilograms then. Okay. Calculate the mass of the water. That is heated but not used during the day. So if I have 6 cups and there is 300 grams of waste per cup, then I end up with 1.8 or 1,800 grams or 1.8 kilograms of waste per day. Letter B, kind of a straightforward Q equals mc delta T, specific heat question. In fact, we're deducing, so it's giving us the answer. So we're going to use Q equals mc delta T. Listing out my variables, I have m, c, T initial, and T final. Mass 1.8 kilograms, C 4.2 times 10 to the third joules, kilogram, Kelvin. Initial temperature in Celsius 18. Final temperature, we're going to boil it, so it's going to be 100 degrees Celsius. The change in temperature then is going to be 82 degrees Celsius or 82 K. Into my equation, 1.8 without units, 4.2 times 10 to the third times 82, and that should give you, when you multiply it all out, 6.2 times 10 to the fifth joules per day. Okay. The third part, letter C, is there's very little physics, all just unit analysis, essentially. So I want to know, estimate the cost of energy that is used per year to heat water that is not used to make tea. So ultimately down here, I'm going to come up with a dollar value. In order to get that dollar value, I'm going to have to multiply a few things out. So let's look at a few ratios that I have, or a few knowns. I have 1.0 megajoules is equal to 0.035 dollars. I know that 1 megajoule is equal to 10 to the 6th joules. And I want to know that conversion because I have joules up here in my letter B. I have joules, so I need to have joules down here. I know that 1 year is 365 days, and I know that in 1 day I waste 6.2 times 10 to the 5th joules. So using my conversions, let's start backwards. So I want to finish with dollars. So I have a ratio between dollars and megajoules. Now working backwards, megajoules. And I want to start with 1 year. Megajoules to joules. Now, do I have something with joules in it? Yes, I do. I have 6.2 times 10 to the 5th joules per 1 day. And in days, I have 365 days in 1 year. And now in order to find this value, all I need to do is multiply things out. So I'm going to take 1 times 365 times 6.2 times 10 to the 5th times $0.035, all divided by, don't forget to divide by the 10 to the 6th, and that should give you your answer. Please put your answer in the comments below and we'll discuss who is correct and who is not. Okay? So look in comments. Thank you.